Hello everyone. Today we are going to discuss about the third part of this topic, unsymmetrical bending. Myself, Mr. Mintu Kalita, Assistant Professor, Civil Engineering, Assam Downtown University. So we have already discussed about the introduction part of unsymmetrical bending and some derivation, how we need to find out the principal axis, second moment of area about a particular area. Today in this video we will discuss about the Mohr circle of second moment of area. For that we need to construct the Mohr circle as by following the following step. So first of all we need to set up the axis for second moment of area horizontally and product second moment of area vertically. We need to plot the points A and B represented by IXX, IYY and IYY, IXY. So after that we need to join AB and construct a circle with this as diameter. This is then the Mohr circle. Since the principal moment of area are those about the axis which is zero product, second moment of area, they are given by the points where the circle cuts the horizontal axis. Thus, OC and OD are the principal second moment of area, IV and IU. The point A represent values on the x-axis and B those for the y-axis. Thus, in order to determine the second moment of area about some other axis, example, the neutral axis at some angle alpha counterclockwise to the x-axis, construct a line from G at an angle twice alpha counterclockwise to GA on the Mohr construction to cut the circle in point A. The horizontal coordinate of n then gives the value of I through the neutral axis. The procedure is therefore identical to that for determining the direct stress on some plane inclined at alpha to the plane on which sigma x acts in Mohr stress circle construction, that is angle are double on Mohr circle, as you can see in this figure. So follow this figure and the steps, you will easily understand. Next we will discuss about the Land circle of second moment of area. This is an alternative graphical solution to the Mohr procedure has been developed by Land, as you can see in the figure. So we need to follow the following step. From O as origin of the given XY axis, mark of land OA is equal to IXX and AB is equal to IYY on the vertical axis. After that we need to draw a circle with OB as diameter and center C. This is then Land circle of second. So after that, from point A, mark of AD equal IXS parallel with the x-axis. After that we need to join the center of the circle C to D and produce to cut the circle in E and F. Then ED is equal to IV and DF is equal to IU are the principal moments of area about the principal axis OB and OU, the position of which are found by joining OE and OF. The principal axes are thus inclined at the angle theta to the OX and Y axis. So how we are finding out the moment of area in terms of principal values? In this figure shows any plane section having coordinate axis XX and YY are principal axis UU and P is passing through the centroid O. Any element of area DA will then have coordinate XY and UV respectively for those two sets of axes. So similarly as we did in the earlier part, to find out the moment about any axis we need to follow the similar process to find out the IXX, as we need to integration I square dA. So we have to put the value of y square. By simple integration we need to find out this. So as we can know, for any moment of area through the principal axis, the product moment of area is always 0. So by putting that value we need to find out that I axis value. Similarly, by following the same steps we can find out the value of IYY, moment of inertia along the y-axis. After that, by finding out the x and y-axis, we have to find out the product moment of area about the y-axis by putting the value of x and y. By simplifying, we will finally get the value which is given in the equation number 1.12. So by simplification, again we need to put all the values. By simplification, we have to find out the tan cos theta, and finally we will get the value of IU and IV. So please go through the following steps. Hope you will learn something from this. Thank you so much. See you again.